Hi guys, welcome to our online learning of organic chemistry. So we have here the first part of our lectures, and we have to discuss the nomenclature of organic compounds, hopefully until the second week of May. Now, this is the topic outline that I want to discuss to you. So we'll look up how we give names for alkanes and branch alkanes. So basically, this is just a review of what we have discussed in the past lectures. Then we have to look at the namings of alkyl halides, alcohol cycloalkanes. So you have here the full list of organic molecules that we will study. And in the end, I will teach you how to give names for organic molecules containing more than one functional group. Okay, so basically we start off with giving names for alkanes, and when we give names for organic compounds, we actually use or follow the rules set by the International Union of Pure and Applied Chemistry, IUPAC. So basically, the fundamental principle of this one is that each organic molecule should have a unique name, something like that. Okay, so for alkanes, we know that alkanes ends in ane, and we use some Greek and Latin prefixes to denote the number of carbon atoms. So we have here, for example, well, if we start with 1, that is meth. If we have 2, that is eth. If we have 3 carbon alkane, that is prop. If we have 4 alkane carbon, when we use the prefix but. And if we have 5, then carbon alkane, then we use the prefix pent. Now, if we continue on with the use of this Greek and Latin prefixes to denote the number of carbons for unbranched alkanes, okay, so when I say unbranched alkanes, these are simply the straight chain alkanes, or sometimes in some textbooks they call this one as normal alkanes. Now, if you have 6 carbon alkane, then you have hexane, 7 carbon alkane, that is heptane, octane, nonane, and decane. I think you're all familiar with this first 10 alkane molecules. Okay, so if alkanes become, or if we have an alkane and if we remove one of the hydrogens, then we will have or end up an alkyl group. Okay, so an alkyl group, basically this becomes a branches. For example, how do we give names for this one? So alkane, if you have an alkane, we just drop the A and E and replace that one with YL. So if we have, for example, methane, that is CH3H. So if you remove one of the hydrogens, it becomes CH3. This is known as the alkyl group. Okay, so specifically, this is known as methyl. So in the same manner, if we have ethane, that is CH3, CH2, H, if we remove one of the hydrogens here, this becomes a CH3CH2, and this is an alkyl group. So the proper name for this one is ethyl. So again, we drop the A and E and replace this one with YL. So another easy example is this one. If we have propane, if we remove one of the hydrogens, okay, so we drop the A and E, then this group becomes a propyl. Okay, now, how do we give names for branched alkanes? So these branched alkanes, these are no longer your normal alkanes. They have some substituents or branch points, okay? So the first rule for naming alkanes or branch alkanes and for any other molecules, organic molecules, is to select or look up the longest continuous carbon chain. Okay, and this will be your parent. For example, if we have here, let's say this molecule, okay, so on the left side, okay, the red portion here, you have 7 carbons, but on the right side, you have the blue carbon atoms here, and that is only 6 carbons. So this rule tells us, okay, to select the longest continuous carbon chain and name it as a parent. So basically, we will use this, we'll choose this one because numbering this in this manner will give us more carbon atoms than this one. Okay, so for the meantime, okay, don't bother yourself where you got 3 methyl. So the parent name becomes heptane because this one has 7 carbon atoms. Now, if we continue, okay, if we have only one substituent, okay, how will you number the parent chain? So basically, this tells these rules here, rules 2 and rules 3. Basically, I will just summarize it in such a way that you have to number the parents chain in such a way the numbering starts at the end nearest the first branch point. Again, numbering start at the nearest branch point. Example, if we have this, okay, if I number it as 1, 2, 3, 4, 5, 6, 7, then the first branch point is at carbon number 3. However, if I number it in this manner, let's say 1, 2, 3, 4, 5, 6, 7, I would notice that my first branch point occurs at carbon number 5. And this rule 2 and rule 3 tells us that we have to number the parent chain in such a way that numbering starts at the first or nearest the first branch point. So we number it in this manner: 1, 2, 3 to 7, something like that. Okay, so we have here 3-methyl. Why 3-methyl? Because 3 denotes the carbon to which your methyl or the alkyl group is attached to. So if you look at this one, this is an alkyl group, a methyl group, a CH3 attached to a carbon atom here. So we have 3-methyl heptane. Now, if we have 2 or more substituents, okay, then you need to number the chain in such a way that will give you the lowest possible combination of numbers, okay? And if we have the same substituents, we can use di, tri, tetra, etc., something like, or etc., something like that, okay? And we have to list the substituents or the alkyl groups alphabetically. So we have some examples to show this one. Let's say this, okay? Okay, so if we have, for example, this one, this molecule, it's known as 6-ethyl-2-methyloctane. Okay, so numbering, the parent has 8 carbon atoms, and numbering starts on this side. Okay, so if numbering starts on this side, we have 1, 2, 3, 4, 5, 6, 7, 8. So we've noticed that the first branch point occurs at carbon 2, and the second branch point occurs at carbon number 6. So we have to identify, for example, what are these branch points or branches, or what are these alkyl groups rather. Okay, so at carbon number 2 we have a CH3. I hope you know why this one is CH3. And then on carbon 6 we have a CH2, a CH3. So this is an ethyl group and this is a methyl group. Again, the rule says that when you try to give the name for this one, then the substituents should be listed alphabetically. So ethyl obviously is written first, than methyl. And obviously don't forget to write the carbon atoms to which these alkyl groups are attached. For example, methyl group is attached to carbon 2. That's why you have 2-methyl. Carbons in carbon 6, you have an ethyl group. Okay, so hopefully you know what is wrong with this molecule. So this one, it's obviously wrongly named. It says 3-ethyl-7-methyloctane. So what is wrong with this is that the numbering of the parent chain, okay? Numbering was done from right going to the left. So it's 1, 2, 3, 4, 5, 6, 7, 8. And if you do that, okay, you have a 3-7 combination, which is higher than your, let's say, 2-6 combination, something like that. We also have another wrong way of naming, which is shown this way, right? So naming is done as 2-methyl-6-ethyloctane. So it should be apparent to you that's the wrong thing, or the wrong thing that's done here. The incorrect thing that's been done here is that the methyl group was written first, followed by the ethyl group. Again, alphabetical precedence. Please do remember that. Okay, now if I have, for example, let's say 2 alkyl groups bonded or attached to a single carbon, then you have to write, okay, or the number twice. For example, you have this 4-ethyl 4-methyloctane. At carbon 4, you have an ethyl group and you have a methyl group. So 4 is actually used twice. So 4-ethyl 4-methyl, because it tells us at carbon 4 you have an ethyl group. At a carbon 4 as well, you have a methyl group. Now, the sixth rule basically tells us that if we have identical substituents, then we use ditritetraenone. I think I've mentioned this one earlier. So, for example, if I have this, it's 2,4-dimethylhexane. Why hexane? Because obviously the parent chain has 6 carbons. That's the longest continuous carbon chain. Numbering starts at the end nearest the first branch point. So I will start numbering on this carbon. So 1, 2, 3, 4, 5, and 6. So at carbons 2 and carbon 4, okay, you have a methyl group. So these groups are the same. So I use the prefix di, so dimethyl. And obviously we have to write the position to which these methyl groups are bonded to, that's carbon 2 and 4. So numbers are separated by a comma, and a number and a word is separated by a dash. Okay, so what is wrong with this one? So 3,5-dimethylhexane, what is wrong with this? Okay, you would notice that the parent is still hexane. This one is right. You have methyl groups here, but what is wrong with this? It's the manner on how we counted the parent. Okay, so for example, in this case, you counted at this ends 1, 2, 3, 4, 5, 6. If you follow this, then you will have a bigger set, higher set of locants. So 3,5 is higher than 2,4. Okay, another example is this one. It's named as 2,4,5-trimethylheptane. So tri means you have 3 methyl groups, and 2, 4, and 5. This is the position to which your methyl groups are bonded, or sometimes this is called the locants, L-O-C-A-N-T-S, locants. Okay, so what is wrong with this? Again, in this example, the way on how we give the numbers to the parent chain is wrong, because we have numbered this in such a way that the numbering started at the end, that is here. Okay, so 1, 2, 3, 4, 5, 6, 7. Doing so will give you a higher set of locants as compared to this one. Okay, so if you continue on, okay, the problem is if you look at the parent and sometimes there's a chain, okay, of equal lengths that would compete for the selection of a parent. Okay, so for example, if I have this, let's say 1, 2, 3, 4, 5, 6, 7 versus 1, 2, 3, 4, 5, 6, 7. If you notice this chain, it has 7 carbon atoms. Now, if you notice this chain, it has 7 carbon atoms as well. So these two chains compete for the selection of a parent. Now, what is the rule here? The rule here actually is to choose the parent which has the most number of substituents or branch points. Okay, choose the chain with a greater number of substituents. So in this case, I will have to count how many substituents if this will be my parent chain. Okay, so let's count 1, 2, 3, and 4. So 4 substituents. In this case, I have only 1, 2, and this big thing here, that is my third substituent. So only 3 substituents. So this, when we apply this rule, this chain will win. So the name will be 2,3,5-trimethyl-4-propyl-heptane. So again, the parent has 7 carbon atoms. That's the longest continuous carbon chain. Then you number the chain at the end nearest the first branch point. So I will number it from this carbon, going from 1 2, 3, 4, 5, 6, 7, and then I have noticed that I have 3 the same substituents, that is a methyl group here, a methyl group, and a methyl group, and these are bonded at carbons 2, 3, and 5. So I have 2, 3, 5 here. And then I have a propyl group at carbon 4. Now if I write the full name of this, then I have to alphabetize. So obviously I know that methyl comes first before propyl. Now your prefixes such as di, tri, tetra, they are not used for alphabetization. Okay, now when branching first occurs at an equal distance from either end of the longest continuous carbon chain, then choose the name that gives the lowest number of at the first point of difference. Okay, so example, if I have this, let's say 1, 2, 3, 4, 5, 6. Okay, now versus this one, it's the same molecule, but it's a different way of numbering. So this one I number on this end, I start numbering from this end, 1, 2, 3, 4, 5, and 6. What's the difference? Basically like they have the same number of carbon atoms. That's the longest carbon chain. Well, at 6, so hexane, that is hexane. How will I break the tie? So choose the number that gives the lowest number of the first point of difference. So in this case, if I count from here, it's 1, 2, 3. Okay, so if I count 1, 2, so there's no point of difference because in this case, 2 and 2. But if I continue, this becomes 3. There's no substituent. So in this case, if I count 3 here, then there's another substituent here. So this one, okay, way of numbering wins. Okay, so 1, 2, 3, 4, 5, 6. Okay, so this becomes 2, 3, 5 trimethyl hexane. Okay, so how do we give names for branched alkyl groups? Okay, so we start off with 3 carbon atoms. So in this case, if you what is this? If you notice, what is this like square thing here? This just represents, for example, the main alkane chain. Okay, so these are just this ones highlighted in color are just the alkyl groups. So if you have a CH2, CH2, CH3, that is a propyl group. If you have, for example, this group here, which is a CH3, CH3, this one is an isopropyl group. This is a common substituent that you need to know by heart. Now, in IUPAC, the name for this one is called 1-methyl ethyl. Why is it called 1-methyl ethyl? Because, okay, the one is carbon 1, and then if you proceed, this is carbon 2. So at carbon 1, you have a methyl group. Okay, so this becomes, the parent becomes ethyl, and at carbon 1, which is the branch point, this is, you have a methyl group here. So it's known as 1-methyl ethyl. If you have 4 carbon groups, okay, we start off with the simplest one. This is butyl group. So you have a CH2, 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 CH3. Now, this is nice because you will always find, it's common, so you will find this one again when we proceed our lectures. This is known as the isobutyl group. Okay, so you have a CH2, I should say, CH3, and CH3. Sorry. Now we also have here, for example, let's say a sec-butyl group. Okay, the name for this one is 1-methyl propyl. Why is it called 1-methyl propyl? Because if this, considering that this is the branch point, then this becomes carbon 1, and then carbon 2 and carbon 3. This will be the longest continuous carbon chain of this branch of this alkyl group. And then at carbon 1, you have a methyl group. So this is known as 1-methyl propyl. Now, this one, okay, it has a funny structure. Okay, this is known as tert-butyl. These are non-IUPAC names, okay? The isobutyl, sec-butyl, and the tert-butyl, these are common names, right? So if this one is the IUPAC name, the systematic name for the tert-butyl is actually 1,1-dimethyl ethyl. So why is it called this way? Because considering that this carbon is your first, is a branch point, this becomes carbon 1. And then, so 1, 2. So this one is your parent chain. And if you notice that carbon 1, you have two methyl groups, this one and this one. So you have 1,1-dimethyl ethyl. Okay. Now, if I have a 5-carbon group, 1, 2, 3, 4, 5. Okay, so this one is known as your neopentyl group. Okay, so why is it? What's the systematic name for this? This one is known as 2,2-dimethyl propyl. Why? Again, considering that this one is this square thing here is your alkyl chain. Now this one is the branch point. This becomes carbon 1 with respect to your alkyl group. So 1, 2, 3, that is 3 carbon, that is propyl. And if you notice at carbon 2, you have methyl group here and another methyl group here. So you have 2-dimethyl, and both of them are connected to carbon 2. So it's 2,2-dimethyl propyl. Okay. Now, let's try to apply what we've learned so far, the rules that we've learned, and let's try to see this, the name for this molecule. So you have here this molecule. Okay, so again, we have to find the longest continuous carbon chain, and that becomes our parent. Now, there are possible choices, obviously. So we can you can count it like this, and that will give you 6 carbon chain. If you count it this way in letter B, okay, you have a 7 carbon chain. Obviously, A is no longer our choice as compared to with respect to B. And if I have C, if I count it this way, I have 8 carbon chain. Now, obviously, B is no longer our choice. This is because it has 7 carbon chains. Now, another option is D. Now, in this case, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so obviously you would know which one wins, and this is D because this one has the most number of carbon atoms. Okay. Now, once we selected it, okay, 9-carbon alkane, that is known as nonane. The next thing we have to do is to decide where to number, or where we start numbering the parent chain. So again, we have 2 ways. We have 2 possible ways here. Okay, we can number it in this way. We can start from this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, or we can also just start on this side, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what does the rule tells us? Again, we have to start numbering at the end nearest the first branch point, or the locants, the set of locants that we should get should be the lowest possible combination. So let's take a look at this case. Okay, so if I number it as 1, 2, 3, 4, 5, and 6, then the combination of locants that I will get is 5, 6. Now, let's take a look at this way. 1, 2, 3, 4, 5. So if I number it this in this manner, I would have 4 and 5. So obviously this, okay, should be followed. This way of numbering the alkyl chain must be followed because we'll have a 4, 5 set of locants as compared to your 5, 6. With that one, okay, settled, we know that this one will win, lowest numbering. Okay, now the next thing we have to do is to know what are the substituents present or connected at those locants. Now, at carbon 4, okay, you have this blue thing here. Now, I hope you are familiar that this one is your isopropyl. Okay, and this one thing here, okay, at carbon 5 is your third butyl. Okay, so isopropyl at carbon 4 and third butyl group at carbon 5. So we have here 4 isopropyl, this one, because you have to ask yourself, where is your isopropyl connected? It's connected to carbon 4, that's why it's 4-propyl. So where's your third butyl connected? It's at carbon 5 of the parent chain, so it's 5-third butyl. So now we know, okay, the number of carbons in your parent chain that is no name. We are now settled with the numbering of the parent chain, and we now know the substituents that are present in the parent chain. The only thing left for us is how to write the full name of this one. Okay, so we use the IUPAC rules to do this. Thing is, we have to list all the substituents first, followed by obviously the parent. Now, when you list the substituents, we have to make sure that the substituents are listed in alphabetical precedence. The common error of students is to arrange this one according to the numbers. No, you should write or arrange the substituents according to the alphabetical precedence. Okay. Now, remember that, okay, isopropyl, okay, is actually included in alphabetization, but third butyl is not included. This third here is not included for alphabetization. So if you have third butyl, okay, we use the butyl as a basis for alphabetization. Okay, so the final name for this one will become 5-third butyl for isopropyl nonane. Again, these ones are the substituents in alphabetical precedence, and this one is the parent. So let's try to consider this molecule. So this molecule looks simple, but it's a bit complex to give name for this one. Now, again, just like what we did in the first example, we have to choose or look for the longest continuous carbon chain, and that can be done by counting the number of carbons, the longest continuous carbon chain, or the carbonate, the chain which has the most number of carbon becomes the parent. So we have possible options here, A, B, and C. So if you look at A, it has 8 carbons, B would have 9, and C would have 10 carbons. So this one will actually win because it has 10 carbon atoms. So that parent will become the king. Now, the next thing we have to do is to decide how are we going to number the chain. So we can number this one from left going to right, or from right going to the left. So that can only be decided if we can have, for example, the lowest set of possible locants. Now, if you look at this, okay, that's 5 and 6 if we number from left to right, and it will also give us 5, 6 actually if we number this one from right to left. So in any manner of numbering the parent chain, this will both give us, let's say, 5, 6 as the combination of locants. So how do we break this tie? So let's look at the succeeding rules for this one. So it has something to do actually with the names of the locants. Now, if we have here obviously your sec-butyl, you should recognize that this one is sec-butyl and this one is neopentyl. So which comes first? So is it 5 sec-butyl, 6 neopentyl, or is it 5 neopentyl sec-butyl? So this one can be solved by looking at the names of the substituents. So if we have sec-butyl, okay, we actually use the butyl or refer the butyl, not the sec during alphabetization. However, if we have neopentyl, okay, alphabetization starts with the letter N. So this means that it is 5-sec-butyl and 6-neopentyl. So if you write the complete name, it becomes 5-sec-butyl, 6-neopentyl decane. Again, these are all the substituents listed alphabetically, and this one will be the parent.